Today we are going to see in the webinar sessions about the LiDAR technologies and its applications. So the table of contents I'm going to cover in these webinar sessions about the LiDAR and types of LiDAR surveys and LiDAR survey flight plan, how to how to make a flight plans, and how the point cloud data it is going to be visualized, and what are the different modes in that point cloud data, and how much accuracy can be achieved by using the lidar technologies and drone technologies, and what are the softwares we need to use for the for pre-planning softwares, for pre-planning and post flight surveys. And I'm just to showcase that sample data, how the data is going to be visualized, and what are the use cases can be derived from the sample data. So I just moving to that lidar definitions. So before I'm going to explain about lidar, so I just give some details about why the people are required for the lidar technologies, and how it was explored, and how that lidar technologies came to the pictures and to the world. So as we know that, like in the geospatial technologies, there are so many technologies that will be involved in that, like a conventional survey method, like a total station, and DGPS and theodolite survey. And then after GIS, it comes into the picture, and then the remote sensing, and then the photogrammetry, and then lidar. So by using that, the conventional survey methods and GIS and the remote sensing, the people, the scientists, or the R&D people wants to explore the more to resolve the world, to resolve the issues of what is going on to world, especially for the natural calamities. So whatever they are getting the data, it is in the format of 2D, till that by using the remote sensing technologies. As we know that, remote sensing technologies will be capture the images directly through the satellites, that it is in the 2D dimensions. But that data, it is not sufficient for them to go for the more for further analysis, like a flood mapping, for change detection, so for urban planning and all. So they got introduced, and they explored something using by photogrammetry and lidar technologies, which it can gives that directly the 3D point cloud data information through the sensors, through the lidar sensors. Right. So I hope you might understand that, what is going to be the lidar. But I'm just keen point to that. Like, I'm again and again I'm using the 3D point cloud data, DSM DEM. So I will explain you that later on, for upcoming the slides. First, you need to understand what is a lidar. So lidar, which stands for light detection and ranging, is a remote sensing method that uses a light in the form of a pulse laser to measure ranges, like a variable distance to the earth. So what will happen, this lidar technologies are working in the active sensor modes, the sensors will the laser pulses are targeted to the ground, and then it will go back to the sensor. Then the data will be stored in that point format. So I will explain in that for upcoming slides, what are the instruments are going to be used in the airborne lidars or in the drones, and what are the instruments, or what are the equipment, what are the major equipments are using in that, by collecting the data using the airborne lidar, terrestrial lidar, drones or mobile lidar. So I will just explain that next slide. So I just move on to the next slides. As you said that about lidar, that it is like a light detection and ranging. It's a remote sensing technique that measures ranges to the earth using light in the form of a pulsar laser. So when these light pulses are integrated with the additional data collected by the aerial systems, exact 3D information about the earth shapes and surface properties is generated. So let's say, just to think about that, when you're flying in that aircraft, I think most of them have the experience to fly that, use that aircraft, airplane, right? So in the flight, when you're flying and take up that, like you can see that features, the real world features, what are the features are present in that ground level. So the same kind of things is working in that lidar. So when the aircraft it's ready to go for the survey, they will integrate the two sensors. One is that, lidar sensor, and another one is that aerial images sensors. So both the sensors will automatically collect the data as per their planning. So we can see that real world virtual world the data in the systems. So what is again the lidar survey? So there are so many pulse like infrared pulse and return echo and coincident discrete echo. Oh, and there are some waveform echoes also it's involved in that by hitting the laser pulses to the ground. So there will be like a three, 4 to 5 different echoes will be there, like a first pulse, second pulse, or first echo, second echo. So echo means it doesn't mean that like you can see the images over here. Let me. So you can see the images, the aircraft, the laser pulses, like the regular waves are coming to the ground, right? So what it will happen, the laser pulses, it is hit to the ground, it is hit to the trees in the top portions, and then it will come to directly to the ground. So there are so many pulses or so many echoes will be involved in that, like a first pulse, first echo, as I mentioned below that. So there are so many informations will be carried in the single point. The single point will have that like 1,000, 2,000 information, the attribute information. The each point is having the echo information, point color information like RGB information, and then that XYZ information, and then timestamp information. So I will explain that what are the attribute informations and why it is necessary that information. So for for to store the data, and how important that information so for the further process and analysis. So as I said that like there are so many instruments are required, or so many equipments are required for collecting the data, or for going for the airborne lidar survey, or mobile lidar survey, or terrestrial lidar survey. So I'm just going to explain about that instruments, what are the instruments are going to be involved in that. So lidar is often defined as the combination of three technologies into a single system capable of collecting data and producing precise digital elevation models, DEMS. These technologies are like, as I said, that it is working in that light pulsar lasers technologies. And then it is required the GPS and internal initial navigation systems or initial measurement unit, IMU. So why it is required? Why want to integrate the GPS and all into the system? So we just wants to understand like where the aircraft are flying, where which position is it there, and then whatever the data we are going to get by using the airborne lidar survey, it is the georeference, the data. So for the georeference data, we have to use the global position systems technologies. As you know that you are using GPS or DGPS, you might aware of it. You might having in your mobile also. So directly it will give the XYZ information. So what will happen in the initial navigation INS? So INS will give you that the information about that uh, aircraft roll, pitch, and yeah. So what it is that the orientation of the orientation of the aircraft, like it is going moving forward, or it is rotating here and there. So all the informations we will get it by using these initial navigation systems equipment. So you can see that there are some GPS are available in these images. The satellites are there, and then they place that base locations. So it is communicating the base locations to the satellites, and those satellites are integrated with that the aircraft, and then the laser pulses are coming to the ground, and it is going return back to the aircraft. So this is the general methodology and the process are working in that airborne lidar technologies, or mobile lidar, or terrestrial lidar, whatever. So this is the systems how it is going to be work while collecting, while the data, while in the data acquisition part. So when you use that point positioning of the footprint. So I told you that like a cell laser beam, so footprint when it is strike on the object, so it will go back to the aircraft. So I have already explained that like methodology and the process of how the airborne lidar systems are working. So you can see that the same images are visible in the screen, the aircraft and the laser pulses. So airborne lidar instrumentations uses a laser scanner, which it transmits laser pulses and records the time delay between a light pulse transmission and reception out to calculate the evaluation values. So there are so many background calculations will be happen, like what is the distance, what is the travel distance between the from the aircraft to the ground, and because based on the timestamps value that as I said that like each points carrying or storing the timestamps informations. So based on the timestamp informations, the all the XYZ informations will be stored in that systems. So and then the data from the aircraft systems like as I said that like we will get that very precise information, the XYZ informations we will get from the GPS, and then orientation, pitch, roll, and ER data from Oriental from internal measurement technologies to produce point cloud data. And each data point is recorded with a precise horizontal position, vertical elevation, and other attribute values, which means the other attribute values means, as I said, that like there are so many like 1,000, 2,000 informations will be stored in the single points. RGB informations, echo informations, timestamp informations, intensity informations. So based on that information, so like how to how to visualize the data and how to extract the information from the data. For that, so these are the attribute informations are required or must. So now you can imagine it like what we can see that the satellite images only it is in the RGB or false color composites. So when we are seeing that when we can go for the airborne lidar survey, you can get it that 3D elevations modules, I mean 3D point cloud data, and you can get it that ortho rectified images or aerial imageries. So you can combine together and you can do the analysis, whatever analysis you want, that you can extract the information and you can produce that 100% precise results. So you can see that I told you that in the previous slides what is the return and what is the echo. So the lidar systems will record multiple returns of the same pulse. So let's say I'm just I'm just using the laser pulses to give to any one objects. If there is no obstacles, so my laser pulses it will go beyond to that. That is the same concepts are working in this here also. So the single same laser pulses it is coming to the ground. So in the meanwhile, there if there is any obstacles, if there is any obstacles like buildings or trees or whatever, the laser pulses it will go till the ground level, and it will store the information like first return, second return, third return, first echo, second echo, third echo. So why we require these informations into that, that once you are going for the applications, so you will come to know like I need to use the first echo, I need to use the second echo, like for the forestry mapping I need only the tree canopies, I don't want to the ground value. So you can use that only that echo, so you can filter out. So in such cases a beam may hit the top of the canopy. So while part of the beam travels further and may hit more leaves or branches, and some of the beam are likely to hit ground and get reflected back. So as I say that like the laser pulses it will go directly to the ground level, and if there is any very dense forest areas, it will go for only two returns. If there is no dense areas, then it will go till the last returns. So you can see the point cloud data like what is the first return, second and third return, and it will rename into that like a first return or last return or intermediate return. So the end up with a set of recorded multiple returns, each having the XYZ positions or informations will carry or will be stored in that the single points. This features advantages in classifying vegetations, buildings, and ground. So as you said, you can something you can understand like where it will be happen. So when we are collecting the data from the airborne lidar or mobile lidar drones, it will give the single point. Like let's say the points are being that default by default, or it's any one in classes on classes. So now I just want to segregate into the multiple classes, or I just want to classify the data in different layers or different classes. Let's say I have the point cloud data in for any particular locations, for any like a settlements areas. So my clients or someone is asking me like I just want to different classes in this point cloud data. So what I can do, like I can select the particular returns and I can classify the data. So this is the returns from the first to start. I just want to these returns are in that trees or buildings. So that you can do it in the software. There are so many software that I will come into the next part. I will explain in the very detail how to classify the data and all. So I'm just going to cover now the types of lidar surveys. So as I said that like there are three different lidars surveys are there: airborne lidar, and mobile lidar, and terrestrial lidar. So the thing is that like the different names and the different instruments are going to be used. When I'm talking about the airborne lidar, you know that like the people are going to use the helicopter or aircraft. So when I'm saying that like a drone technology, the people are going to use the drone. So when I'm saying that mobile lidar, so the people are going to use the, you know, the vehicle which is mounted that scanners on top of the cars or some of the vehicles. So you can see that like the helicopters are going to be used, and then images it's showing that what are the equipments and what are the like how the airborne lidar survey is working. So you just keep in your mind like there are so many internal and external parameters are will be stored in that the each technologies like airborne lidar and mobile lidar. So you need to understand what is the xyz information, what is the role pitch, yeah, how it is working and how the data are varying from these interior and exterior parameters. So that you have to, you know, focus and you have to explore that things, and you can go for the google and you can search it and you can, you know, by yourself you can gain the knowledge. And you can see the sensors like the airborne lidar sensors and the image sensors. So what it will happen when they're going flying that aircraft or helicopter, so they will be mounted that drone, sorry, they will mounted the sensor, the lidar sensor, and aerial sensor, the imagery sensors in bottom of the aircraft. So at a time that airborne means that flight once we create the flight path, based on the flight path the data will be captured by using the lidar sensors as well as by using the aerial imageries. So it will be the parallel activities simultaneously that both the data will be captured. So it will be stored internal equipments like let's say hard disk or something, like they might use the laptop. The data will be stored into that. So as I said that like mobile lidar, so you can see that the people are uh, mounted that scanners in top of that vehicle, right? So you can imagine it like where the people can use that the mobile lidar survey. So mobile lidar survey mostly used for that, like, you know, the railway projects or bridges or road. It will be used for the linear projects. So if they want to cover that, you know, the road furnitures or railway furnitures, they can use that mobile lidar survey. But the methodology of the lidar, sorry, airborne lidar and mobile lidar, it's a very similar methodology. They will use the IMU, they will use the GCS, they will use the GNSS equipment, and the way the data it is going to be captured will be different, and the data calibration part will be the same comparatively the airborne lidar and mobile lidar. Why I'm integrating these points into that, when I move into the terrestrial lidar survey, it is totally different. So I will explain you that how it is the data is going to be captured. Now, so you can see that, you know, the terrestrial lidar survey, the people are mounted the tripod, right? So this is the scanner, the laser scanners. Will the data will be captured in the 360 degree of the horizontal and 270 degree of the vertical. So you can easily relate it to these three survey methods: the airborne lidar and mobile lidar and terrestrial lidar. How the data it is going to be visualized. So when we are going for the small scale maps, so the people used to go for that, you know, airborne lidar survey. So when the people are going for the large scale, the people used to prefer that the terrestrial lidar and mobile lidar survey. This is also it's purely you know, depends on the scope of work and what kind of work they are going to be do, and what exactly they are going to get the output. So based on then they will take a call and they will plan accordingly. So how these systems will work? It will work by static method. So once I place that, that systems in one location, it will capture it. This is also the terrestrial lidar scanners. Also, it's very from the, you know, there are a number of players are there in the market who are selling that, you know, the product, that terrestrial laser scanner. We know that like there are so many like Faro, Leica, and there are so many people are there. It's like there are having some, you know, different variations also. They're having like a 300-meter range and 1 kilometer range, 5 kilometer range. So based on this, that the price also will be vary, and the accuracy systems and the system integrations also will be vary. So, do you think that the terrestrial lidar scanner will give you that millions of points in a per within a second? So if it is rotating the 360 degrees, it will give the very real world the pictures, the 3D panoramic images and the point cloud data. So you can easily visualize the data by the human, and they can realize that this data is going to be useful. So mostly that terrestrial lidar surveys are using for the, like, smart city, and for the, BIM perspective, like from scan to beam. So I just move on to the next slide. Yes, now I'm just coming to the part of the drone and the lidar sensors. So you can nowadays the people, most of them vendors or the people are using drone technologies, means drone integration with the lidar sensors. So the reason is that, like, when I'm comparing to the cost, airborne lidar survey, it is very huge. It's like the cost, it is cost effective compared to the drone technology. So that's what, even this is also depends on the, like, exactly what they're going to do. If it is like a 10 square kilometer or 5 square kilometer area, they can go for that. Let's say if they want to cover, like, in a city, the big city, like, 1,000 square kilometer, 2,000 square kilometer, definitely they can go for the drone lidar survey. Definitely they will prefer to go for that airborne lidar survey. So you just think about that, like, there are so many technologies, there are so many types of service are there. Then why the people are using these many service methods, for anyhow, ultimately, using the sensors, it is going to give that the point cloud data or the images, the raster images, right? So then why people are using this? So the reason is that, like, there is some options, means there is some solution, like, there will be like a number of solutions. So based on the solutions, they will choose that. It is very simple. It's very simple, like, what exactly you want, you can choose it, you can pick it out. So now I'm going to explain, like, a bit of that lidar survey process, how to, make a flight plan, and what is the flight plan, and how it is traveling that, the aircraft or drones into the path. So you can see that the people used to say that is the flight plan or trajectories. So based on the trajectories, if once they define that trajectories, and they imported the trajectories into the systems, the software and this aircraft and the base station, it will be combined together, and it will work together, and based on that flight planning, the aircraft or drone will fly in that particular path. So as we know that the drone, there is no, like, a pilot. So for that, the flight plan should be very precise. So based on that flight plan, the drone will flow in the path, and it will capture the data. So in the aircraft or helicopter, obviously the pilot and co-pilot will be there. If there is any issues on the trajectories, they can correct it manually. But in the drone technologies, it is not like that. It is not very similar to the airport, but the data capturing, the data acquisition, 60-70% it is very similar. But rest of the things in the drone, it is fully autonomous. So that the second image, you can see that the point cloud data, which is having the different colors. It is in yellow, green, blue, dark blue, pink, and red. So what does it mean? This is the flight plan. So what is based on the flight plans, the data are capturing. So we can, if you want to switch any one flights, if I want to see, there are so many, like 6 to 7 flights, I want to use only the 5 flights, I can directly go to the particular flights, I can remove it. So the raw data, it looks like this, using the flight plan. So the next is the point cloud data in the different modes. So as I said, that point cloud data will having that lot of attribute informations. So you can see, as I said that in the previous slide, the color by the flight line. The flight line, based on the flight line, we can visualize that point cloud data. So based on that colored by echo, we can see that, and based on the elevations values, we can visualize the data, and based on the intensity. So what it is, why these many options are required. So I'm just giving some example of the intensity. If I want to digitize the water bodies perfectly, so the intensity mode will be very very precise and will be very helpful for the digitization of that, the water bodies, or for the identification any difficult features. So interpretation is very very important in that lidar data. if you are good in interpretation, if you are having the good interpretation skills, then you can play, and you will be the expert in that lidar technologies. So it is very similar to that, the remote sensing. So remote sensing, as I said, that it is giving the false color composite. So if the person doesn't know that what is the images, if he doesn't have the interpretation skills, they cannot work in that remote sensing technologies. I mean, they cannot work in the satellite images. The very similar things like will be applicable for the lidar technologies also. If you don't know how the terrains it's going to be, and which is the water body, and where is the settlements are there, and what are the features are available, so interpretation skills is very highly required for these technologies.